portion of a portfolio that's in asset two. The formula computes the standard deviation of a portfolio with two assets and is used to judge the volatility of the portfolio. The first asset has a variance of 0.05 and the second of 0.1. I mean, those are somewhat random values. I mean, they're values that can't make sense. And I'm just explaining what the numbers are in the formula. I mean, in terms of us as Calc 3 students, the 0.05 and the 0.1 and the 0.25 don't exactly matter, but if somebody knew a little bit about the subject, those numbers do mean something. The standard deviation, again, is a measure of how volatile a portfolio is. Portfolios can certainly have more than two assets, but in order for us to have a 3D function, I limit it to the idea of two. Many of the ideas that we're actually going to study in this section can be used for the formulas that kind of govern this area of finance, but again, you know, in terms of being able to graph things and see a full graph, you know, I've limited us to two. So state a domain that makes sense for this application. This is actually an interesting one because X and Y relate to each other. They're proportions of a portfolio, and we're assuming the portfolio only has two assets. So what has to be the relationship between X and Y? They affect each other, okay? So think about how they affect each other and what has to be true about their relationship. They're the proportions of the two different assets in the portfolio. Ding, 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 ding.
Money.
That should be, as one goes up, the other one has to go up.
As one goes up, the other goes down, and they're limited to,
The amount of money being invested.
well, but they're proportions.
Right.
So if you added the two together, it can't be more than one, as in 100%.
Other portfolio?
Well, I'm sorry,
100% of what?
Some money invested.
well, portfolio, your portfolio only has two assets in it. And so if asset one is 30% of it, well, what does asset two have to be taken of? 70%, right? So X plus Y has to add up to one. So your domain, and X has to be positive or zero, and Y has to be positive or zero. So your domain is this plane restricted where X is greater than zero and Y is greater than zero. That's how you're gonna state your domain.
No shorting.
Wait, what?
I said no shorting.
Yeah, right, yeah, exactly. So, I mean, if I graph it, if I graph the domain on here, okay, let's remove. So X plus Y has to equal 1, and why don't I limit our, well here I'll graph, but then we'll limit our window so that X is positive and Y is positive. And we know the two have to add up to 1. We know the two have to add up to 1, so I guess I should have made Z. Okay, so that's kind of showing you that it's this plane that sort of slices across the XY axis. Our domain is actually out of the, I mean, I graphed a plane so you could see it, but our domain would actually be if you drew a picture of it. This applet only draws in 3D. Well, I guess I could get around that by doing a contour plot. But let's do, yeah, I don't think it'll do a contour plot on the implicit functions. It might, but I have to. So that's why I drew it in 3D. But the actual domain, when X is 1, Y is 0, and when X is 0, Y is 1, so it's just this little segment is actually your domain, okay? So anyway, it's a different, it looks different than when, you know, we're in algebra class. We now have two different domains, and then in terms of our application, it doesn't make sense for X and Y to add up to anything different than one. I mean, it's not even that it has to be less than one, they have to add up to one. Okay, then the range, well, what do we know about square root functions?
They're always positive.
They're always positive. In terms of, I mean, generally, I would say that, you know, Z, you're tempted to just say, well, Z has to be positive, but we know that X plus Y has to add up to one, and so that actually, it's not gonna go all the way down to 0. But it looks like, it kind of looks like a half. No, because this is 0.35. I wonder if we took 0.05 and left X in, and then we know that Y has to be 1 minus X. I'm going to graph this on the TI graphing calculator and see if we can get a minimum for it. Okay? So square root of 0.05 x squared plus 0.1 y, but we know y and x are related, that they have to add up to 1, so y is 1 minus x squared, and then plus 0.5 times x times 1 minus x. 1, 2, 3, 4, 5, 6 parentheses, it looks like, okay.
There's a, oh, never mind.
Okay. And then I'm gonna go into the, I'm gonna go into the table just to, get an idea of what kind of numbers we have, and then I'll graph. So the numbers are kind of in the points, and so I'll, let's see, 0 to 1. Y is what we're actually computing, so I'll just go 0 to 1 on it also. Okay, so, interesting, it looks like we're hitting a maximum too, and our minimum looks like it's over here. Because we know, remember, we know that X and Y are limited by 1, so I've set the window correctly, so actually that, let me just go up here and plug in. Let's just plug in 1.22. Okay, now it goes lower, but X can't be 1.1, so 0.22 looks like it's the lowest. And then looking at the graph again, we actually do have a max, so.
That 0.22, that's at the, if it's all in X.
Right, okay.
Um,
Oh, so if it's all, yeah.
Y would be 0, right?
Yeah, you know, that would be interesting if you,
It's the square root of 5 over 10.
yeah. No, I was trying to think, I wonder if we rewrote it so that I rewrote X as 1 minus Y, if that's gonna change it. Well, I'll do that in a second. Let me find this maximum real quick. I'm just gonna run the max program. looks like it was what we're hitting the maximum. So right now off of that, our range looks like, it's going from approximately 0.22 to 0.4053. Again, it's approximately, I'm gonna rewrite it so that so this is gonna become one, I have to type X because the calculator only has X, but it's really like, X is 1 minus Y, and then Y, and then plus 0.5, this can actually stay the same because it was, you're just multiplying X and Y together. So all I've done is I've switched what was X with Y, and let's graph and see if, yeah, okay, see, do you see how the minimum's now over here? So it's gonna be the same 0.22. It's just over there now. Okay, so my range is approximately 0.22 to 0.4053. Okay, for this situation with these particular covariance values and so forth. Okay, so.
Sorry, on the, back on the formula, shouldn't it be, that 0.5 times x minus x squared? Because you're multiplying x by what we're putting in for y, which is 1 minus x.
Oh, wait, hang on, did I put 0.05? I'm just trying to.
No, you put 0.5.
Yeah,
Okay,
0.5.
Robert, I don't, like this is, if I let y be itself, then
Right.
x is 1 minus y.
Oh,
My
I didn't see the
calculator-
second, I didn't see the second line down there. That's all it
Okay,
was.
all right. All right, so we did domain and range. And, I mean, by the way, you guys, you should be able to take a situation like this and reason out what we came up with here, okay? It should not be beyond your capabilities. I know due to the mechanical things you guys have been exposed to for the most part, I know you're not used to having to dig into things, but you know, just, I'm mentioning this because I do, if you're given an application and you're at home and you don't, you know, it's not crunch time, you should take the time to kind of think through a situation. In the long run, I mean, that's kind of what people have to do when they're really applying things, you know, they have to think through. Okay, so I'm going through these examples, kind of modeling for you the type of thinking that you need to start to do. Okay, so we start off in class kind of working on it together, but, you know, you should be able to launch off from this.